we will get started. Thank you everybody for joining us for week 5 of our Healthy Hardy Heifer series. Today we are going to be going over reproduction and reproductive strategies for those pre-breeding heifers. So just as a reminder that we are on week 5 and we still have 3 more weeks to go. So next week we're going to be talking about how to manage those bred heifers, and then we have pre-calving nutrition and pre-calving comfort and facilities to end it off before American Thanksgiving. So want to say thank you again to all of our sponsors for making this possible for us to offer this for free for all of our participants. So thank you to Diamond V, Zinpro, Pool and Grain, and Arm & Hammer. And as a reminder, also, all of our previous week's recordings and slides are available on Box, and we will put that link in the chat again in case you have not been able to access it. And sometime next week, these slides and this recording will become available as well. Thank you. Casey just put that in the chat. So that is the link to the recordings. So this week we have Dr. Julio Giordano from Cornell University. He is an associate professor of dairy cattle biology and management, and he is going to be talking to us today all about reproductive strategies. So I will stop sharing and let you share your slides, Julio. So you got about 35 minutes or so, Julio, so we'll start cutting you off as we get closer to about 12:40.
Excellent. Thanks a lot, Lindsay, for your introduction. And thanks to the whole team for inviting me to participate of this program. It is always a pleasure to share our research and outreach information with you. I'm hoping that we can have some time for discussion at the end, that we can talk about repro in heifers. So today I'm going to touch on some of the latest research that has been done in this area, as well as my experiences working with commercial farms that we collaborate with. So to start with, I just want to briefly go over some concepts or premises that I'm pretty sure that most people can agree on, and we could spend a lot of time talking about this because there's a lot of research data to support these concepts or these ideas. But I prefer that we talk a little bit more about how to do this rather than about the motivations that we have to reduce days to pregnancy, and through that, reduce age at first calving in heifers. And research data has very clearly shown that reducing days to pregnancy has several positive effects on the heifer enterprise and the dairy as a whole. Among those ones, probably the most important is that reducing days to pregnancy, once that heifers become eligible to get pregnant, will increase or have positive effects on the heifer enterprise profitability. So the system as a whole will be more profitable, and there is very little question about that. Reducing days to pregnancy will also not compromise productivity and the reproductive performance of our future first lactation cows, provided that during that first lactation and before they get to that first lactation, these animals are fed well and are managed well. So once that we have made the decision to start breeding these animals, if we reduce the interval from that time point and pregnancy, we are not going to have negative effects on productivity and future reproductive performance. The other concept that I would like to highlight now is that it is possible to reduce days to pregnancy for most herds. So we do have the tools, we do have the strategy, and that's specifically what we're going to be talking about today, and that in general, the ability to reduce days to pregnancy is a management decision, because for most heifers, for most herds, we don't tend to have biological limitations from the heifers that will impede, that will not let us achieve the goal of reducing days to pregnancy. And once again, the premise for today, the premise with this concept of reducing days to pregnancy and thus reducing age at first calving, is that we have this heifer, we have this animal that has been fed and has been managed to a point that has reached the adequate size to become pregnant. And after this day or this time point at which this animal has reached this point, we have to get them pregnant as soon as possible. Okay, so we are not here, we're not going to discuss today how do we get them to this point that they become eligible for pregnancy. So we are saying here, now we have them, they are ready to get going. How do we get them pregnant as soon as possible? So when you look at heifer repro performance across multiple herds in the US or in the Northeast, one of the most common issues that we observe are problems with the service rate or the speed at which heifers are inseminated after they become eligible for pregnancy. This is a table that I have shown to many people many times in my presentations, looking at critical reproductive performance outcomes like the 21-day service rate, the conception rate, and the 21-day pregnancy rate for heifers and for cows in the same herds. And even though there is, of course, a lot of variation across herds, overall, when you look at these critical parameters, what stands out the most is the fact that the service rate in heifers, it is not as high as it could be and as it should be. And very interestingly, it is on average lower than for lactating cows. So in this data set of 10 herds across New York State, 18 percentage point lower service rate, 21-day service rate for heifers than for cows, which is fantastic that we have such good service rate for cows, but it's telling us something, and it's telling us that we are probably not doing as great of a job with heifers, because the reasons why we have a good service rate in cows is because farms are paying attention, farms are putting the effort on having a good service rate with cows, but things are falling behind, things are not going as well with the heifer herd. And the most interesting thing about this is that estrus expression, which is very important for the service rate, in particular for heifers, because a lot of our herds continue to use programs that rely a lot on detection of estrus and do hormonal intervention. The thing is that with heifers, estrus expression, so the ability of these animals to show estrus, in general, is not a problem, or at least it should not be a problem. Heifers do not have the same limitations to express estrus than cows, than lactating cows have. They are not making milk, they are less metabolically challenged, they have fewer health issues, at least they don't have the early lactation health issues that have important implications for expression of estrus in lactating cows. So as long as heifers, again, and I keep repeating this like a broken record sometimes, as well as if they're well fed, they are in good health, they didn't suffer too much when they were calves, and they are provided reasonable environmental conditions, we should not see issues with these animals, with this group of animals in dairy herds expressing estrus. And in my experience, or if you look at research data, that tends to be the case for the majority of commercial herds. So based on that premise is that we know we see, and I'll make the case today, that when we use programs to submit heifers for insemination that rely primarily or almost exclusively on detection of estrus, that those simple types of programs can work really well for heifers. So we're talking about pretty much no hormonal intervention, no application of any hormonal treatments to promote estrus expression or to synchronize ovulation. If we have a very simple program that relies just on detection of estrus in heifers, it is likely that it will work well. So we know through research, we know through experience with commercial farms that we work with, that can work well. It may not be ideal. So it may not be ideal from the perspective of the pregnancy rate that we observe, and therefore the economics of these type of programs for heifers. But if the goal is to get heifers pregnant in a reasonable time frame after they become eligible for pregnancy, we know that it can work. On the other hand, to speed things up a little bit more, what we can do is promote estrus expression. We can use simple or relatively simple treatments to, instead of just waiting heifers to spontaneously show estrus, to try to promote estrus expression. And that can be simply done through the use of prostaglandin treatments or progesterone-based protocols or progesterone supplementation-based protocols. These are also pretty effective, and they are effective because at least the prostaglandin-based programs, they need for heifers to be cyclic when they receive prostaglandins. And again, in a vast majority of our herds with well-maintained animals, well-fed animals, a vast majority of heifers are going to be cyclic. So these programs, which very simply use prostaglandin F2 alpha treatments, and here I included some commercial names that you probably are more familiar with. So when I'm talking about PGF, I'm talking about this commonly used commercially available products. And these programs, which can be implemented either at the beginning of the breeding period, so we could start the very first day that heifers become eligible for pregnancy, whether that's done with just age or some indication of size, such as height or body weight. It consists of simply giving heifers prostaglandin treatments, hoping that we are going to synchronize estrus. So we're going to see a lot of these heifers in estrus after these prostaglandin treatments. And then we're going to inseminate all the heifers that we detect in estrus. Now, not all heifers will show estrus. So using more than one treatment, so waiting 11 or 14 days to give a subsequent treatment, it is very typical. So those heifers that were not yet inseminated in estrus after the previous prostaglandin, they receive a second one, and then we just continue with estrus detection until they are inseminated, or they are detected pregnant, or they are no longer eligible for breeding. So very simple, just give prostaglandin treatments to promote estrus expression, try to group estrus events and inseminate a high proportion of them after these prostaglandins. We know that in general, a lot of them are going to show estrus. It's going to be anywhere from 70 to 80% of heifers will show estrus after a single prostaglandin. And then when you give the second prostaglandin, probably another 10–15% will show estrus. So it is possible to inseminate the vast majority of them just after a couple of these prostaglandin treatments, or maybe 3 treatments. With 3, you almost get them all. The other option, again, is to use progesterone-based protocols or programs. In this case, we are going to synchronize estrus with the use of an intravaginal progesterone-releasing device. So the commercially available product is the Cedar device, which I'm sure most of you are familiar with. So this is also very simple. It's just a little more involved that we have to insert the progesterone-releasing device. So we put in on the group of animals that we're trying to synchronize estrus, we put the device in intravaginally, we keep that device for 7 days, we remove it. At the time of removal, give a prostaglandin treatment, which will help with synchronizing estrus if heifers were cyclic, if they already had a CL on their ovaries, and we expect that a high proportion of them will show estrus. In this case, it's going to be also maybe 80, 85, in some cases 90% of the heifers will express estrus after this protocol. So very simple. The device goes in, we wait 7 days, remove, give the prostaglandin, and then expect that the heifers show estrus and are inseminated. So again, the approach here is to try to inseminate animals that detected estrus, and we can go from no hormonal intervention to some level of hormonal intervention. How do these programs work and how do they compare to other type of strategies, such as more involved use of hormonal treatments like Time AI? I have here an example of a type of strategy in this group that we recently evaluated in a research trial. And basically the idea was to inseminate as many heifers that detected estrus as possible. So we started in this case during the trial with a prostaglandin treatment at the end of the voluntary waiting period. So when heifers became eligible for breeding, everybody receives the prostaglandin treatment. Giving them every 14 days is probably a lot more practical than 11 days. 11 days works, but 14 days works too, and is more practical than 11 days. And in this case, we gave up to 3 prostaglandin treatments, 14 days apart. And then the heifers that were not inseminated detected estrus, which we expect to be none or very few, they are going to go through a Time AI protocol. So we want to make sure that everybody is bred within a reasonable amount of time. And for example, in our research trial, we had 99% of the heifers inseminated after these 3 prostaglandin treatments. So only 1% needed to go through the Time AI. So again, you see that it is possible to inseminate the vast majority of them through promotion of estrus with simple prostaglandin treatments. And I'm going to talk later a little bit more in detail about this 5-day dosing protocol that I have listed in here. This work that we conducted showed that this type of strategy does work. It can be effective to get a good pregnancy rate. It leads to reasonable pregnancy rate, somewhat comparable to programs that use more Time AI. However, a critical piece, just as you would expect for any of these programs that rely a lot on detection of estrus, is that you have to have really good estrus detection. So that's something that from the get-go, we have to make sure that that's the case. And then from the profitability, so then you wonder, so what about, so it works, we know, we have proven that. Now, how do they compare from the profitability perspective? And what we have learned is that they may not maximize profitability as compared to some of the programs that use Time AI a little more aggressively. And I'll get back to that in a moment. So effective, yes. Do these programs optimize or maximize profitability? Probably not. So estrus detection is key for this. And that's something that farms should be aware of, and before they embark into these type of programs, make the decision of having a really good estrus detection program. There is no secret. Heifers are really good expressing estrus. We can use any of the traditional methods, visual, tail pain removal, estrus detection patches, proven to work really, really well. But I wanted to comment a little bit on the alternative that we have today for estrus detection, that is automated estrus detection. As you may be aware of, there are many systems out there to detect estrus automatically and potentially help farms that struggle with traditional methods or prefer to go into some of these technologies to use this for detection of estrus. So very simply, to the question of do these technologies do these systems work for heifers? Lots of work has been done traditionally with lactating cows. Now there is a little bit more work looking at how these systems work for heifers. So a couple of studies that have been recently done have shown that they work. As an example, one study in which a relatively popular system with a neck tag was used. What was observed is that there were no significant differences in the ability of the automated estrus detection system to detect heifers in estrus as compared to tail head mounted detectors. So it worked as well as the tail head mounted scratch patches. Okay, it was neither better nor worse. And it was the same from the perspective of heifers detected in estrus. And there were also no differences in terms of conception rates or pregnancies per AI for the heifers that were inseminated. You can see 50% pregnancies per AI for heifers detected in estrus by the automated system or the tail head mounted detectors, and no differences for the few heifers, for the smaller proportion of heifers that received an embryo instead of artificial insemination. So at least it worked as well as those mounting detectors. Another study, in this case, a study out of Canada that looked at the ear attached version of the same system. So the ear attached sensor also found that in this case, a vast majority of the heifers that were detected in estrus by a reference method, once again, the estrus detection tailhead patches was pretty good. So a vast majority of the heifers were detected, more than 90%, and there were not a lot, less than 10% of false positive alerts. The estimated sensitivity was about 91%, and the false positive rate, which is the inverse of the specificity, was about 8%. So again, comparable to some of the traditional methods, they don't seem to be any better or worse. I do have to emphasize again that at least this, these values, these comparisons, that they are coming from research conditions, right? If you have a herd that's, again, that struggles with traditional methods, if estrus detection is poor with a traditional method, there is a very high chance that these automated systems are going to help to improve estrus detection efficiency. But when you compare them to estrus detection done well with traditional methods, there is not at least a statistically significant difference that was demonstrated in favor of the automated estrus detection systems. So as a message, these technologies are clearly a useful tool that could be incorporated into reproductive management programs, in particular, again, for farms that want to use estrus detection as the primary method of submission to first insemination. So they may be a pretty good solution for farms that want to use estrus detection and don't want to use or cannot implement a traditional estrus detection program. Now, let's touch a little bit on Time AI. We have effective programs to submit heifers for insemination with Time AI. We know that, and I'm going to discuss that in a moment. However, as you would expect, this synchronization of ovulation protocols for Time AI, they will require multiple hormonal injections, the use of intravaginal progesterone releasing devices. So they are more complex to implement, and therefore it could be a struggle for some farms to implement them. Because of the hormones, the labor to implement them, they of course are going to be or could be more expensive to implement than the programs that rely more on estrus detection. However, as a message, and this is again based on the research that we have done, I'll touch on this again in a moment. It has been shown many times that yes, they can be more costly to implement, but at the end of the day, because of the effect that they have on reducing days to pregnancy, they can be more profitable than the programs that rely exclusively or almost exclusively on detection of estrus. The 5-day Cosynch protocol with progesterone supplementation, which you have displayed here, is what we have today as the most effective protocol to synchronize ovulation for time AI in dairy heifers. So this has been proven to be the best protocol of all. So if a farm wants to optimize conception rate, if they want to optimize pregnancies per AI through time AI, this would certainly be a protocol to consider implementing for that goal. This protocol consists of an initial GnRH treatment. So we just grab a group of heifers that are random stages of the estrous cycle that are ready to be inseminated. So we're going to start with a GnRH treatment, a progesterone releasing device, again, an intravaginal progesterone releasing device. 5 days after the GnRH and the device went in, we're going to remove the device. We're going to give the first prostaglandin treatment. The next day, so what, 24 hours later, we give a second prostaglandin. And within 48 hours of that second prostaglandin, or 72 hours of the timing of seeder removal, we give GnRH again and we breed. So in heifers, we can use Cosynch, which you see is the name of the protocol. We can breed and give GnRH at the same time, and that is going to be effective. A very common question from people is, what do we do if heifers show estrus after we remove the progesterone releasing device? If you detect them in estrus, breed. We know that those heifers do really well if they are bred in estrus, and that they are very likely going to do better if they are bred in estrus than if we wait to breed them through time AI. Research has shown and experience with commercial farms that the expected conception rate of pregnancies per AI with this type of protocol is going to be in the 60 to 65% range. Now, it's quite involved. There are several injections. Researchers have explored multiple ways to simplify these protocols, make them cheaper, easier to implement. An alternative version of the 5-day Cosynch protocol that is simpler and involves less treatments and injections is what I have in here. The difference with the previous one is that there is no GnRH to start with, and we only give a single prostaglandin treatment. And I just noticed that I have a minor error here. So this is 3 days. This should be 3 days from device removal to prostaglandin up to the time of insemination. 3 days, not 2 days. I apologize for that error. So again, the difference with the previous one is no GnRH to start with and no second prostaglandin treatment. And there are physiological reasons for this that I'm happy to discuss later, but I will not discuss now. So if we use this, the expectation has to be for lower pregnancies per AI. It is likely that it's going to be in the 50 to 55% range, just because of these treatments that we are removing from the protocol. So again, we have the option with all the treatments that has been shown to optimize fertility, and we have a simpler option that works, that is effective, however, is not going to maximize fertility. So now going back, so those are just protocols, right? So what can we do for time AI? Now taking you back to programs for first insemination. So how can we use these protocols? An option to use time AI is to not use time AI for all heifers, but rather to combine estrus detection with time AI. And that is what we do with this type of program. This will be like almost like a pre-sync example. What we do a lot in cows, that is giving prostaglandins 14 days apart, either the second one at the end of the voluntary waiting period or the first one at the end of the voluntary waiting period. You could do both. Here, I just have this as an example. Breed as many heifers that detected estrus as possible. And then the ones that are not bred at detected estrus are the ones that go through the time AI protocols that I should show you. So we are using time AIs as a safety net and make sure that we are breeding these heifers within a short time frame after the end of their voluntary waiting period. The alternative is to be a lot more aggressive and use 100% time AI for first insemination. So we synchronize them all. We can match the end of the voluntary waiting period to when we pull the seeder. So those ones that show estrus, after the seeder is removed, we can breed them and they're going to be bred within a short time frame after the end of the voluntary waiting period. But within 3 days of when heifers become eligible, everyone is bred. So we are taking advantage of the effect of time AI on reducing days to breeding or reducing days to pregnancy. So this will be the most aggressive in the spectrum of trying to use time AI. Our recent work has shown that these two types of programs work really, really well. We observed that they improve the pregnancy rate as compared to the program with the 3 prostaglandins that I showed. And they have also been shown to increase or maximize profitability as compared to the old AIE programs, the programs that use more insemination detected estrus. Okay, so they work. Are they more expensive? Yes, but at the end of the day, they lead to better pregnancy rates and they lead to improved profitability as compared to the programs that rely more on detection of estrus. So they are very effective and they can be really good for farms that especially struggle with estrus detection. Very quickly, I want to bring up another important concept that we cannot forget about for heifers. It's not all about just the first breeding. Unfortunately, we have some heifers that don't get pregnant at first insemination and we have to rebreed. So we need to have a pretty good program for rebreeding heifers. We can take advantage in heifers of the really good estrus expression that they will present. So most dairies can do really well. This is one example. I'm showing you a dairy that is capable of re-inseminating 92% of the heifers are detected estrus before 45 days of the previous breeding. And they only need to do something different. Use some sort of synchronization, use time AI for 8% of the heifers that are, as you can see, they are synchronized and they are re-inseminated within a relatively decent time frame after the previous breeding. So we don't have a lot of heifers that go for too long without being re-inseminated. This also depends on having a pretty good pregnancy testing program that in this case is implemented weekly. So we know which heifers are open and we have to try to work with to rebreed as soon as possible. And now I'm showing you a little bit of an extreme example, but this is a farm that I was just looking at yesterday and looking at the rebreeding dynamic for the herd. And you can see how in this herd, there's about 30% of the heifers that are re-inseminated beyond 45 days of the previous insemination. And even more problematic are all these heifers that are being re-inseminated a long time after the previous re-insemination. This is a farm for which pregnancy testing is done monthly, and there's no synchronization of ovulation and time AI use whatsoever for second and subsequent breedings. So the message is that, yes, we want to always use as much estrus detection as possible for rebreeding heifers. That works well. But it's also important, in particular for those farms that are not as good with heat detection, to have a pregnancy testing program in place. And when those heifers are found open, do something with them, which could be using the same time AI programs that we use for first insemination, or any sort of time AI program that we can use to put semen on those heifers as soon as possible after they are detected non-pregnant. So using any type of time AI program will help reduce days to rebreeding. And this is more important for those herds that have poor estrus detection. An alternative to this would be to instead of putting them straight into the Time AI program, to just give them a prostaglandin. So the open heifers on the day of pregnancy testing receive a prostaglandin, hoping that we're going to have some of them show estrus. After that time point, we wait 14 days, and after that, we put them into some sort of Time AI program. So we are always using Time AI as our safety net to make sure that heifers are re-inseminated at a reasonable time frame after the previous insemination. Again, if I take you back to this herd that I use as an example, we need to avoid having all these many heifers, all these many animals going for so long without being re-inseminated and losing a lot of time, getting pregnant later, which is not what we want. So I walk you through several strategies to submit heifers for insemination, and we went all the way through the range of almost exclusively or exclusively based on insemination of detected estrus to more aggressive use of Time AI and combinations thereof. Clearly, we have simple programs that can be used to promote insemination of heifers that detected estrus, and we have programs that are more complex that use Time AI. So we have them, they are available, they are effective. As I said at the very beginning, it's a management choice. Okay, as managers, we have to decide what's best for our operation with our conditions, with our resources to implement for our heifers. We can achieve optimal repro performance with programs that rely exclusively or almost exclusively on detection of estrus. However, in this case, estrus detection efficiency is going to be key. If we fail at detecting heifers in estrus, we're not going to do that well. Combined programs, that is those ones that first attempt to inseminate heifers that detected estrus and use Time AI only for the ones not detected in estrus, or those ones that are a lot more aggressive that use Time AI from the get-go for first breeding, are very effective, and research has shown that they can be more profitable than programs that, again, work well with predominant estrus detection, but are not as profitable as these ones. And this was the case even for farms with really good estrus detection. In the research that we have done, even for farms with excellent estrus detection efficiency, the programs that use Time AI a little more aggressively led to better profitability than the programs that use less Time AI. And last but not least, consider the use of an aggressive rebreeding program, including some form of pregnancy testing and some form of Time AI, either for all heifers that are found open or for those ones that are given a second chance to be inseminated at detected estrus and they are not. Okay? It's not just about the first breeding program. It's also what we do with those heifers that don't settle after the first insemination. We need to rebreed those ones as soon as we can. With that, I conclude my presentation, but I would not like to finish without acknowledging the people that make my research possible, my group, so my graduate students, technicians, the commercial farms that work with us, that collaborate with us on our research, the companies that support our research, and of course, the institutions and funding organizations that support our research. Thanks for your attention, and I will be happy to answer any questions you may have.
Thank you, Julio. That was awesome. And I have to say congratulations. That's the closest you've come to finishing on time, I think.
There you go. I'm learning.
Only 2 minutes over. That's awesome. Thank you. So I just posted in the chat, just a reminder that if anyone has any questions, to post them in the chat or the Q&A. So we'll just give people a minute to do that. My computer's glitching, so I apologize. 1 second. There we go. Let's see.
Julio, while we wait for some questions, can you touch a little bit on breeding size versus breeding age and in that conversation a little bit.
Okay, very good. Yeah, that's an important conversation to have always at farms. And I'll say that I'm not an expert in the field, other than to say that, again, like I emphasized at the very beginning, that we want to make sure that whenever we implement these effective programs to get heifers pregnant as soon as possible, that we start with a heifer or heifers that are at the right size or age, but size should be the outcome to become pregnant. So ideally is size rather than age. And based on the research that has been done over the years with heifer size, breeding, pregnancy, and then performance as a first lactation animal or as an adult animal, the criteria should be about 55% of adult body weight. So heifers should become eligible for insemination where they are about 55% of adult body weight, and that's an important piece there. So ideally, we know what is the adult body weight for the herd of interest, given the differences in cow size or frame across dairy farms. Ideally, we know what is the size of adult cows of the herd of interest. Based on that, we estimate what 55% looks like, what is that approximate body weight, and therefore we start breeding them when they reach that weight. And the idea is that they become pregnant by the time that they are about 60%. And then it's important to think about how quickly we get them pregnant, right? And how long it takes for them to go from that 55 to that 60% that we want them to have when they become pregnant. So what I would say is that if the program that we are implementing is very effective at getting them pregnant very quickly, let's say that we use a 100% time AI program, that we breed them all once that they become eligible, you have to be careful because you're going to be getting a lot of them pregnant at 55%, right? So in that case, if you have a very aggressive program, maybe wait a little bit more, get a little bit closer to that 60% that you want to have and adjust, right? So you have to play with those, with those things, depending on how aggressive the program is and how effective it is at getting them pregnant. And of course, then don't forget what happens after they become pregnant. And I see that you have the next talk. Focus on that, right? Because one of the issues that we see in a lot of herds is that we get them pregnant and then the trajectory of those heifers after they become pregnant is not ideal, and then they don't calve at the right size. But I'll let the other speakers discuss that.
Perfect, thanks, Julio. And then we did have a question. Kim asked, she said, looking for sources of AED products.
Okay, so the question is about what companies, I guess,
I'm assuming, yeah,
commercialize automated estrus detection systems. So today we have several companies in the United States that commercialize this. I don't know if Kim is based in the US or not, but I say in the United States and all over the world, there are several companies that commercialize this automated estrus detection systems. And I don't want to leave anybody out. Okay, I'll just mention some of the commonly seen ones in commercial farms. You have, for example, the system that many people know as the SCR system. SCR has been bought as a company first by Allflex. So you may also see Allflex. It's actually called now Allflex Livestock Intelligence, but it's actually so it was bought by Merck. So the pharmaceutical company Merck owns now the company Allflex Livestock Intelligence that commercializes these products. Then you have a lot of the companies that commercialize parlor equipment. You have De Laval, GEA, Affimilk, Bowmatic. For robotic herds, Lely, De Laval, again, most of them also sell this automated estrus detection systems. Then you have Cow Manager that is commercialized by Select Sire. So many of the AI companies now also commercialize these products. Alta Genetics commercializes a product. CMEX commercializes a product as well. So there are many options out there, and apologies if I forgot to mention one of the commonly found ones, but those are the ones that come to mind right now.
Great. All right, well, thank you very much, Julio. So we will wrap up today's session. As a reminder, next week we're going to be talking about bred heifers, and then we have 2 more sessions to talk about pre-calving. And again, thank you to our sponsors for making this possible. And the slides from this session and the recording will be posted next week. And also, as a reminder, when you close out of Zoom today, and a survey should automatically pop up. Please fill that out and provide us with feedback. Helps us better design our programs for the future. So thank you again, Julio, and thanks everybody for joining us.
You're welcome. Thanks a lot.